All right, class, let's look at section 1.8, Introduction to Functions. Our goal here is to use 4 different ways to represent functions. Some vocab we need to look through. First, let's define a function. A function is a rule that establishes a relationship between two quantities called the input and the output. Now, in order for a function, well, let me say this, in order for a relation, so something that just relates two sets of numbers, to be called a function, there has to be exactly one output for each input. That's the main rule. There has to be exactly one output for each input. Next, input. An input is a value in the domain of a function. So input, we also call the domain. This is typically x values. Now, of course, we don't always use x and y, but typically it's our x values. Then our output, we like to call the range. And this is typically our y values. So input x value, output y value. We'll be making input-output tables. It's just a table used to describe a function by listing the outputs for several different inputs. So we'll have values of x either given or we choose them, and then we list the corresponding y values. You'll see what that looks like in just a moment. Domain of function. The domain of a function is the collection of all input values of a function. So again, domain goes with input, and then range. The range of a function is the collection of all output values of a function. Domain goes with input, range goes with output. Lots of very important vocabulary there. Lots of very important vocabulary. Let's start by creating an input-output table. So here's what we're going to do. We're going to make an input-output table for y is equal to x squared. Alright? Y is equal to x squared. That's the relation we're looking at. For our x values, we're going to use 0, 1, 2, and 3. Alright? So you'll see for our input, we put in that 0, 1, 2, and 3. Now to figure out our output, we need to use that y is equal to x squared. So let's do that. So what we're going to do here, use this color. We are going to evaluate y is equal to x squared for these different values of x. Let's start by plugging in the first input they want us to look at, 0. So y is equal to 0 squared. So when x is 0, y is 0. Actually, we're going to change that color a little bit. Let's make it this color. There we go. Next, let's plug in our next input value they want us to use, 1. So when x is 1, we get y is equal to 1 squared, which is just 1. So when x is 1, y is 1. Next, let's use our next input value. This time they want us to use x equals 2. So we plug that into our function. So when x is equal to 2, y is equal to 2 squared, which is 4. So when x is 2, y is 4. And the last one they want us to evaluate is when x is equal to 3. So when x is equal to 3, my y is equal to 3 squared, or 9. So what just happened is they gave us inputs, okay? They gave us inputs, and we used the function y is equal to x squared to find our outputs. So for the second part, they ask us, does the table represent a function? Justify your answer. Here's what you want to look for here. If you remember back to the definition of a function, it said that every input needs to have exactly one output. If you look, every input has exactly one output, okay? We're not repeating any input values, so therefore we would say yes. Because for each input, there is exactly one output. Another useful way to do this is to list all the inputs, so in this case 0, 1, 2, and 3. Then list all the outputs, in this case 0, 1, 4, and 9. And then we map them. That's why I like to call them map it. So you look, 0 corresponds with 0. 1 corresponds with 1. 2 corresponds with 4. And 3 corresponds with 9. It's not necessary you do this, but this is just another way to picture it. As you can see, every input goes to exactly one output. Therefore, we have a function. Let's do another one. So let's go down to our checkpoint problem. This one we're going to make an input-output table for y is equal to 2x minus 1. So that is the rule we need to follow. The rule we're going to follow to find our y values is y is equal to 2 times x minus 1. And they want us to use the input values of 1, 2, 3, and 4. So let's go ahead and do that. Let's start by making a little table. There we go. So this will be my x values, this will be my corresponding y values. They want us to use x values of 1, 2, 3, and 4. And to figure out our y values, we're going to have to use this rule. So, like I said, our rule this time is y is equal to 2x minus 1. So what we're going to do is we're going to plug in the x values we have right here and solve from there. The first x value I have, let's actually make these a little different color. You know how I like to color code stuff. There we go. So we'll make our x values that light blue color. First x value I'm going to plug in is 1. So we plug in 1 for x. And now we need to evaluate using our rule to find y. So y is equal to 2 times 1 is 2 minus 1, which gives us y is equal to 2 minus 1 or 1. So what that tells me is when x is 1, y is 1. Let's now evaluate for x equals 2. So we plug in 2 for x. So y is equal to 2 times 2 is 4 minus 1. Or y is equal to 3. So what this tells me is when x is equal to 2, y is equal to 3. Let's evaluate at our next x value. This time we're going to evaluate at x equals 3. So let's do that. So y is equal to 2 times 3, which is 6 minus 1. So y is equal to 5. So when x is 3, y is 5. And last, we evaluate when x is equal to 4. So we plug in 4 for x, and we use our rule to find y. So y is equal to 2 times 4, which is 8 minus 1, or y is equal to 7. So when x is 4, y is 7. Now, does this represent a function? Well, let's do that mapping thing I was just talking about. So we list out our x values, which in this case was 1, 2, 3, and 4. Then we list out our y values, 1, 3, 5, and 7. And then we map them. So looking at our table, there we go. Looking at our table, 1 goes with 1, 2 goes with 3, 3 goes with 5, and 4 goes with 7. And as you can see, every input, okay, so all those light blue values, every input only has 1 green arrow coming off of it, meaning every input has exactly 1 output, which means it's a function. Great, let's keep moving. Now, we are going to skip example 2 for now. We will come back to this when we are in class together. All right, I want to make the table and graph this all while we are together. We are, however, going to look at example 3. We're going to look at example 3. Now, a little bit earlier in this chapter, we skipped a section where they put together these models, they call them. Now, these are very helpful. Like I told you, I want to read equations as if they were a sentence. I want to read equations as if they were a sentence. And what this does, and this kind of helps us put together an equation if we put all the information like it is a sentence. All right? So we call this a verbal model. Let's see what we're doing. So, to fix a car, a mechanic tells the owner that the parts will cost $270. The cost for the mechanic to fix the car is $35 per hour. Write an equation to represent the total cost of the repair C as a function of the hours H it takes to fix the car. So let's make sense of this a little bit. You have your car, something goes wrong, you need to get it fixed. Now, if you take it into a mechanic, all right, it doesn't just cost what the parts cost. The mechanic also charges you for labor. Now, labor is charged per hour. In this case, the total cost of the parts they need to use to fix the car is equal to $270. And then the cost of the labor, so the cost of the mechanic actually installing those parts, is $35 per hour. So we want to set up an equation that represents how much it's going to cost us depending on how many hours it takes to fix the car. So our total cost is equal to, we have to take into account the cost of the parts, so cost of parts, and then plus, we also need to take into account the cost per hour. So let's say cost of labor, because they charge labor per hour. So this is kind of a verbal model of what our equation will look like. The total cost is equal to the cost of the parts plus the cost of the labor times how much time they spend on the labor. All right, so cost of labor times the amount of hours. Let's assign some variables. Our total cost will be C. The cost of the parts, well, we already know that. We don't need to assign a variable. They told us the cost of the parts was $270. The cost of the labor, the cost per hour, they told us that labor is $35 per hour. And then we don't know how many hours they're going to work on the car, so we'll call that H. So if we take these labels and we assign it back to our model, the total cost was C is equal to the cost of the parts, 270, plus the cost of the labor, which was $35 per hour, times the amount of hours. So our equation is C is equal to 270 plus 35H. So now you can figure out how much the repair will cost depending on how long it takes the mechanic. One more example. You are buying fabric to make costumes for the school play. The cost of the fabric is $6.40 per yard. Write an equation to represent the total cost of the fabric C as a function of the yards of fabric Y that you buy. Let's use that verbal model again. Let's see if we can use that verbal model. So, total cost. Total cost. And we're going to use C when we write our equation. Or no, we don't want to use C. Oh yeah, C. They did use C, I'm sorry. So the total cost of the fabric will be C. Alright, so our total cost in this case is equal to the cost per yard per yard times the amount of yards. So our total cost is equal to the cost per yard times however many yards we buy. So let's assign some labels here. So my total cost, all right, we're going to use C because that's what they told us to use, is equal to the cost per yard. Now it tells me right here the cost of the fabric is $6.40 per yard. So $6.40 per yard times the amount of yards that we buy. Now, I don't know how many yards we're going to buy. All right? So let's just use a variable there. They tell me to use yards of fabric Y. So we're going to use the variable Y. So our equation is C is equal to $6.40 times the amount of yards I buy. So what we have here is a function that tells us a cost, tells us the cost as a function of how many yards we buy. Okay, so what that means is we can plug in however many yards we want to buy, and then we can figure out the cost by following the rule. All right, your homework can be found on Canvas. Get to it.